Hello, Accelerated Chemistry students. This is Miss Crisafoli, and this is your Chapter 4, Section 1, video notes all over defining what the atom is. So we're going to talk about early models of the atom, and there's going to be a lot of scientists over the next few videos, so I suggest that you keep them straight because I'm going to be eventually quizzing you on who did what. So let's define an atom. So an atom is the smallest particle of an element that retains its identity in a chemical reaction. So early philosophers and scientists did not have the equipment to observe atoms. They were still able to propose ideas about the structure of the atoms, though. They would sit around and talk and discuss, but they didn't have any actual evidence to support what they were saying. So let's start off at the beginning. So let's start off with Democritus. So he was the first person to propose the idea that matter was indivisible and indestructible. And he stated that matter was made up of individual particles, and he called those atomos. And the atom is the smallest piece that any substance can be broken down into. So Democritus coined the term the discontinuous theory of matter, but he was criticized by that because he didn't have any evidence to back it up. Also around this time, we also had Aristotle. Democritus and Aristotle were both Greek philosophers, and Aristotle disagreed with Democritus because he did not believe that empty space could exist. So he believed that matter was made up of earth, air, fire, and water. And so Aristotle's views went unchanged for 2,000 years until the scientific community developed methods to test the validity of his ideas. So if we were to look at these two Greek philosophers' ideals in an overview, Democritus said that matter is composed of atoms. Atoms are solid, homogeneous, indestructible, and indivisible. And there's different kinds of atoms that have different sizes and shapes. And the size, shape, and movement of atoms determines the property of the matter. Aristotle contradicted that by saying that empty space cannot exist, and matter is made of earth, air, fire, and water. These are two very different views of what matter was made of. After those gentlemen were around, Dalton came around in 1766, and he was an English teacher that was fascinated with meteorology. So he revised and revived Democritus' ideas. And he only performed many experiments, made both quantitatively and quantitative observations. And he developed what we call Dalton's atomic theory, and that was adapted in 1803. And it's made up of 6 main principles. So here is his atomic theory. He first said that all matter is composed of atoms. Atoms are indivisible and indestructible. Atoms of a given element are identical in size, mass, and chemical properties. Atoms of a specific element are different from those of another element, and different atoms combined in simple whole number ratios to form compounds. In a chemical reaction, atoms are separated, combined, and rearranged. Those are the main points of his atomic theory. So his atomic theory has been revised over time with the advancement of technology. So he made some modifications. We know now that atoms are divisible. We have protons, neutrons, and electrons in them. And we know that atoms are destructible. And we know that all atoms of the same element are not identical. So if we were to summarize Dalton's theory over the course of his time, we come up with his 6 main principles, and they're listed again on this slide. So this is what we've come up with so far when we talk about the history of the atom. But now let's talk about how we size up the atom. So Dalton's concept of the atom, when we look at it, we can look at it as far as looking at liquid mercury. So every drop, no matter its size, has the same properties as the chemical properties of mercury. A copper coin's the same way. If you were to grind a copper coin into the smallest powder possible, each possible speck of copper dust would have the same properties of copper. And if you were to keep grinding that until you had the smallest possible particle of dust from a copper coin, you would, in theory, have a copper atom. So we know that atoms are very small. So despite their small size, though, individual atoms are observed with instruments such as a scanning electron microscope. This is a picture of what a scanning electron microscope looks like. So the scanning electron microscope allows a beam of electrons to be focused on a sample, and then the electron microscopes are capable of much higher magnification than light microscopes. So individual atoms can be moved around and arranged into patterns so that we can get a clear picture. And because of this, we have the ability to move individual atoms, and we will be able to create atomic size electronic devices such as circuits and computer chips. So here's a diagram of how the scanning electron microscope works. So we have an electron gun that goes through an anode, goes through a magnetic lens, scanning coils, backscattered electron detector, and then all the way at the bottom where the stage is where your specimen is. And we're going to see some pictures from scanning electron microscopes in class, and we're going to be able to look and determine what some possible uses for this information is. And this is the end of your Chapter 4, Section 1 notes. And as always, all the information on these Google Slides has been acquired and adapted from Pearson Chem's 2012 edition of the textbook, resources CD, and pearsonchem.com. Thank you.